Transportation, travel, and tourism. Whereas transportation and logistics have seen a relatively high adoption of AI, travel and tourism have, relative to other sectors, been lagging in both adoption and the future AI demand trajectory. Even though this is the case, there are a variety of impactful AI use cases that will be highlighted here. The transportation industry clearly has high expectations for the impact of smart technology. Transportation's interest in AI is predominantly driven by autonomous vehicles and the transformative impact they are expected to deliver on how metropolitan areas and cities operate. Not only can machine learning powered smart technology solutions provide safe and efficient transportation, but also improve traffic flow, expand the capacity of existing road infrastructure, as well as reduce carbon emissions and facilitate greater inclusiveness. Given that transportation is at the intersection of smart technology and public life, a significant majority of transportation decision makers also are of the opinion that the government should be, to some extent, involved in AI regulation. According to the same KPMG study, these industry leaders are not only almost unanimous about the expected benefits of AI-driven solutions, but also aware of the risks, with most of them feeling that there is also a threat to consumer data privacy or security. The market size for AI-driven solutions in transportation is expected to grow from $1.2 billion in 2017 to $10.3 billion by 2030, which translates to a compound aggregate growth rate of 17.8% over the period. Some relevant use cases for deploying AI solutions in the logistics and transportation sector include streamlining decision-making in transport management driven by AI and IoT, optimizing transport operations, managing warehouses, decreasing downtime and repairs through monitoring and predictive maintenance, going driverless, changing supply chain logistics into automated trading, and demand planning. Freight and logistics are a $4.5 trillion global sector that is highly fragmented, complex, and manual, with a high dependence and cost of human coordination. This market is ripe for disruption, with several startups delivering AI-driven solutions to address these issues. One such startup is Fero, which is focused on eliminating human coordination in freight and logistics and envision bringing AI-enabled coordination to the freight ecosystem through optimization and automation of freight transactions globally. They have implemented a voice-enabled AI-driven virtual freight intelligent virtual assistant that not only coordinates pricing, quotes, customer services, and operations, but also manages sales, bidding, and customer services across various freight functions. Machine learning models can, for example, be used to predict whether a product will be shipped on time and find the most optimal shipping routes. In addition, intelligent systems can help identify problematic incidents and solve them in time. One of the use cases that Cortex Logic has been involved in was to help reduce the risk in transport and logistics for a provider of fleet and mobile asset management solutions. The machine learning powered application was aimed at improving the safety and security of people and assets, reducing cost of operations, and enabling behavioral change of drivers. Such a solution does not only help the fleet management provider to enhance its customer service, but also improve driver safety by predicting a potential accident or harm from driver behavior, and also flag accident-prone behavior for human review and management. The cloud-based AI-driven solution uses existing camera footage to monitor camera obstruction, identify anomalous behavior, for example, driver distraction, cell phone usage, driver fatigue, driver safety belt usage, and smoking, as well as the number of passengers in the vehicle, and integrating the outputs with the current alert processes. The multi-trillion-dollar automotive industry is under heavy disruption with the relentless drive towards electric and self-driving vehicles, along with ride-sharing business models. Tesla has become the most valuable car maker at the time of writing, with ride-sharing giants such as Uber, Lyft, and newcomer Face Drive also disrupting the automotive industry. Even though Tesla has sold a fraction of global car sales with Toyota, Volkswagen, Renault Nissan Alliance, Hyundai Kia, and General Motors being the top 5, it is leading the self-driving car pack. In particular, in the category of self-driving or autopilot miles logged, a total of 3 billion miles as of April 2020 compared to its nearest competitor Waymo, which reported 20 million miles on public roads at the start of 2020. The reason this is an important metric is that self-driving algorithms are based on machine learning, which is dependent on huge volumes of representative sensor data. That is why AI is paving the way for autonomous vehicles or self-driving cars, which can sense its environment through sensors such as inertial instruments, odometry, GPS, radar, LiDAR, and sonar, and moving safely with little or no human input using machine learning and advanced control systems to interpret sensory information for navigation and identification of signage and obstacles. Although we have seen rapid progress with autonomous vehicles due to focused efforts by Tesla, Waymo, General Motors Cruise, Ford's Argo AI, Baidu, Aurora, and others, there are also limits of today's machine learning to specifically deal with the unexpected that needs to be addressed. In addition, there are also hard problems around safety, assurance, data security, ethical issues, social acceptability, and regulation that needs to be overcome. This can only be done with all stakeholders collaborating on making self-driving cars safe and providing the required evidence, along with implementing regulations and standards for autonomous vehicles, and getting the public involved in decisions about the introduction and adoption of these vehicles. In the US, the National Highway Traffic Safety Administration has recently for the first time proposed some amendments to its vehicle safety rules to make it easier for the widespread adoption of self-driving cars. AI will play an increasingly important role as one progresses on SAE international levels of driving automation, going from level 0, where there is no automation, up to level 5, which implies full vehicle autonomy. The levels for automated vehicles are automation for driver assistance, that is hands-on, for example using parking sensors or cruise control. Partially automated driving, which is hands-off, vehicle can perform steering and acceleration, but humans still responsible for vehicle's operation. Conditional automated driving, which is eyes off, human lets the system take control, for example on a highway. High automated driving, which is mind off, human presence still needed and can override the system. And full automated car, which is steering wheel optional, no human assistance required. Some of the advantages of autonomous vehicle technology is increased road safety, reducing accidents and the number of fatalities due to accidents, less traffic congestion, fewer parking problems, reduced driving fatigue, increased productivity, more convenience, more cost-effective mobility options, and helping people not able to drive due to disabilities or age. A machine design article outlines 4 areas where AI can be a game changer to help autonomous vehicles become successful. The first one being safety, where machine learning can assist with the emergency control of the vehicle, braking in emergency cases, syncing with traffic signals, active monitoring of blind spots, and cross-traffic detection. A second area is the curated cloud services with respect to predictive and prescriptive maintenance aimed at individual car owners. AI can also be used to monitor the driver and predict and prescribe user preferences based on user behavior, which might include regulating the air conditioning, adjusting mirrors or seat positions, or playing songs. The fourth area is providing accurate feeds for insurance companies and regulators with regards to driver risk assessment and faster processing of insurance claims. There are also startups such as Hallam.ai and Comma.ai that are working on providing more cost-effective AI solutions to help unlock autonomous driving. Hallam.ai, for example, claims that their deep teaching method can train AI systems 100,000 times cheaper than methods that involves human annotation or simulation typically done for supervised machine learning. By using compressive sensing, which is incorporating structural assumptions about the specific object into the construction process, and sophisticated priors, which is the structural a priori assumptions that an AI system can take for granted about the nature of reality, to scale limited information into deeper insights. Helm.ai, who sees themselves as the Android of self-driving cars, intends to also apply their technology to shipping, industrial machines, delivery robots, and service vehicles. Comma.ai has developed open source software called OpenPilot, which is built to improve upon the existing driver assistance with Tesla Autopilot-like functionality for most new cars on the road today. The AI-driven solution enables a car to steer, accelerate, and brake automatically within its lane. Comma.ai has also launched a $999 kit called Comma 2 that gives cars assisted driving features. Some other examples include Waymo, that is collaborating with Fiat Chrysler Automotive to develop an autonomous delivery van that will be using Waymo's self-driving technology as part of the partnership for Level 4 high automated driving. It is clear that autonomous driverless technology will also be implemented in other vehicles, such as pilotless airplanes, with some experiments done by Boeing, pilotless helicopters, already tested in Dubai and Singapore, autonomous shipping vessels for transport as well as cranes that can load and unload, with Kongsberg in Norway one of the leaders in the autonomous shipping industry. Self-driving tractors to make farming easier. See, for example, Precision Makers that is collaborating with John Deere on this. And delivery drones for shipping, as tested by Amazon. There are also numerous AI use cases in the airline industry that includes air safety and airplane maintenance, flight route optimization, fuel efficiency optimization, revenue management, improved customer experience through in-depth customer feedback analysis and automated personalized messaging, crew management and scheduling, and supply chain optimization for in-flight sales and food supply. For the aviation industry, cancellations and delays are a significant and costly problem, where up to 30% of the total delay time can be attributed to unplanned maintenance. The status of various systems and subsystems on an aircraft that are instrumented by a variety of sensors can be monitored in real time by predictive analytics to help pinpoint existing faults and proactively predict future faults and its associated severity. This in turn leads to reduced downtime or aircraft delays and higher safety. A predictive maintenance solution can help to reduce unplanned maintenance, overtime compensation of crews, and transportation-related expenses for parts. As an example, a leading airline wanted to reduce cancellations and flight delays caused by maintenance-related issues, which were costing them $135 million a year. This problem was addressed by the implementation of a machine learning-based model that predicted 30% of maintenance-related potential cancellations and delays within a 2 to 3 day time window. Synapse MX provides another example of an AI-powered maintenance repair and operations software solution that utilizes maintenance-related data to automate workflows and provide real-time recommendations to assist technical and logistics maintenance staff in their decision-making. They claim to have saved AirTran Airways $68 million annually in direct maintenance labor costs. Spark Cognition's AI solutions have also been deployed at Boeing and the United States Air Force to improve operational efficiencies and predictive maintenance and troubleshooting activities. Their solutions give alerts of aircraft or asset failures before they occur, help to minimize unscheduled maintenance and maximize fleet availability, and help to extend asset life. The AI software also automatically classifies fault code using natural language processing, recommending best corrective actions by analyzing sensor and hangar data, and deploying reinforcement learning in a simulated environment to train control algorithms. Boeing and Spark Cognition are also partnering on a joint venture called SCRIBD to build an AI and blockchain-powered airspace management software platform to help ensure the safe and secure integration of passenger air and autonomous cargo vehicles in the same airspace that they operate. The specific AI components of the platform assist with dynamic traffic routing and provide predictive analytics that enable customers to safely use unmanned aircraft systems with tasks such as package delivery, emergency assistance, and industrial inspections. Airbus has launched an online collaborative platform called AI Gym that presents challenges that describes business problems that Airbus faces within the helicopter, satellite, and commercial aircraft business domains and explores how AI can be used to solve these problems. AI-driven revenue management involves the use of machine learning to provide on-demand service delivery of the right product at the right price using the right channel at the right time and covers dynamic, personalized pricing and price optimization. For airlines to provide optimal customer services and be competitive, AI-based solutions can help to manage seats, recommend destinations, determine efficient distribution channels, and adjust prices for specific markets. Revenue management starts with an analysis of the demanded flight routes, which is followed by determining the customer's willingness to pay and dynamic pricing, assuming that customers will pay more if there is less time before departure time. Then calculating the expected marginal seat revenue, determining whether the expected revenue for a lower class ticket would be higher than a higher fare ticket based on sales probabilities. And finally, the price optimization for ancillary items such as baggage, insurance, rental, and accommodation. AI-driven price optimization and recommendations can be enhanced through the mining of detailed historical data that might include previous flights purchased, seat type preferences, seat upgrades, types of rental and accommodation, frequent flyer account status, social media profiles, and browsing history. Pros Control is an example of dynamic pricing software used by some airlines to do dynamic pricing on some ticket searches. AI systems can also help to optimize flight routes that take into consideration route characteristics, expected level of congestion, flight efficiency, and air navigation charges. Such an AI-driven optimization can have a direct impact on optimally timed and booked flights, an increase in customer retention, as well as lower operational costs. To predict the optimal amount of fuel needed for a flight, machine learning models are also being trained with flight data such as route distance, altitudes, weather, aircraft type, and aircraft weight. In a paper by the Faculty of Aerospace Engineering at Delft University of Technology, the researchers have proposed a two-step optimization framework using a multi-objective evolutionary algorithm based on decomposition for route design and allocation of aircraft to multiple departure routes. The aim of the optimization framework is to minimize fuel consumption and cumulative noise annoyance. They have demonstrated the performance and capabilities of the framework using a case study at Amsterdam Airport Schiphol in the Netherlands, which achieved a reduction of up to 31% in the number of people being annoyed and a reduction in fuel burn of 7.3% relative to the reference case solution. AI solutions can also help to enhance the customer experience to optimize cost and efficiency, grow revenue, and build brand and customer loyalty. One such solution is provided by Amadeus, which enables airlines to provide the traveler with a special customer experience throughout the customer journey, from initial search to booking, from pricing to ticketing, from managing reservations to check-in and departure processes. Amadeus also has a chatbot called Amanda to help approximately 7,500 travel agents around the globe and have on an average day around 27 conversations an hour and answer 63 questions. Pure Strategy's AI-driven analysis solution has also been applied to airline customer experience data to get a 360-degree view on the customer journey, touchpoints, influencers, and path to purchase, as well as automatically extracting insights with respect to sentiment, drivers of customer loyalty and churn, unmet market opportunities, product feedback, and market trends. Another application area is to optimize the scheduling of an airline's crew in order to maximize their time, increase employee retention, and save costs, where flying crew is typically the second largest operating cost item after fuel cost. Jeppeson's crew rostering software helps airlines to build high-quality rosters in a flexible manner while reducing total costs and time to market, which in turn leads to increased profitability. AI can also assist with predicting the number of in-flight sales and the amount of food it has to purchase for a specific flight. Another cost-saving application area for airline and travel companies is to detect potential fraud in suspicious payment transactions with the use of machine learning applied to customers' historical purchase and flight data. Whereas there is a consensus that automated systems have made flying safer, the importance of reliable and robust software, sensors, and operating procedures has been painfully demonstrated with the two fatal crashes of the Boeing ill-fated 737 MAX planes, which killed 346 people. One of the major issues along with training seemed to be linked to design flaws in the Maneuvering Characteristics Augmentation System MCAS flight control software, which ensured that the way the 737 MAX behaved in the air remained consistent and matched that of previous generations of the plane. MCAS relied on data from a single angle of attack sensor in the nose of an aircraft that measures the angle at which it is encountering the airstream. Even though there are two of these sensors, relying on only one of them meant that if it failed, MCAS could, for example, deploy at the wrong time and push the nose of the aircraft down when it was supposed to be climbing. Another issue was that MCAS would deploy repeatedly in cycles, forcing the nose down and again. Even the pilot could use a thumb control to correct the pitch of the aircraft. After a wide range of changes that include updating the flight control software, revising crew procedures, and rerouting of internal wiring, Boeing hopes to have the 737 MAX back in the air in 2021. Although the MCAS system did not include AI elements, there are still lessons to be learned for real-time AI-driven autonomous systems, such as self-driving cars. Given the typical steps involved in the AI driving tasks such as sensor data collection and interpretation, the fusion of sensors, updating of the virtual world model, action planning, and controls command issuance, Lance Elliott highlighted some specific lessons and insight in this regard. Instead of retrofitting prior design, it might be best to start anew. It is better to rely on multiple sensors than a single sensor. For robustness, ensure that sensors are validated via sensor fusion calculations or software sensors. The importance of human-machine interface designs that need to incorporate a spectrum of real-world scenarios with respect to co-sharing and on and off kind of automatic action. Training of human operators so that they can operate optimally and in symbiosis with the AI-powered machine. Ensuring that the human operator of an AI system have a mental model of the scope of the system's capabilities. The need for robust testing of complex systems. Compromises and miscommunications can easily occur within a team or group setups during the design, development, testing, and deployment phases of advanced automation systems, and safety considerations of these systems during the above-mentioned phases. Some examples of airlines that use AI to improve their operations include Delta with their predictive aircraft maintenance and self-service for improved customer experience, EasyJet with their advanced analytics with respect to airplane food supply, aircraft maintenance, and revenue management, and Southwest Airlines with their workforce optimization, customer experience through social media and big data analysis, fuel consumption optimization in partnership with G Aviation using its flight analytics system, and air safety in partnership with NASA using text data mining to detect patterns in flight data and reports aiming at potential safety problems. Before the 2020 coronavirus pandemic, which had an enormous impact on the global travel and tourism market, the size of the global travel and tourism industry was estimated in 2017 at approximately $1.6 trillion and 10.2% of the world's GDP, when adding indirect and induced economic contribution of related activities. Given that most of the impact of AI on this sector will focus on customer services and engagement, it is not surprising to see intelligent virtual assistants and chatbots deployed as virtual travel agents as one of the key application areas. According to reports by Nielsen and 3C, it seems like these intelligent virtual travel assistants are especially popular with millennials with the inclination to control their traveling experience as opposed to older generations for whom brands are influential. Some recent travel industry statistics show that 80% of customers prefer self-service, 74% of travelers use the internet for planning trips, 45% of users use smartphones for vacation planning, and 36% are willing to pay more for an easy-to-use interactive booking process. There are many examples of travel service chatbots that help prospective travelers and customers to make reservations, provide flight or hotel booking assistance, offer traveling suggestions, and answering questions. Examples include those provided by Expedia, Kayak, Booking.com, and a number of travel chatbots on Facebook Messenger, as well as startups such as Hipmunk, Mezi, Snap Travel, Hello Goodbye, and Pana that mainly provide text-based chat travel assistance. I've personally experienced the use of Expedia's customer services chatbot in successfully handling travel cancellations with the onslaught of the COVID-19 pandemic during the first quarter of 2020. Other travel assistance examples include voice-powered hotel reservation systems at hotels as well as AI concierge services with the likes of Amazon's Alexa via its Echo speaker device being used in hotel rooms in virtual assistant capacity for guests. The same holds for Google Assistant via Google Home speaker device and Apple's Siri. According to Gartner, the consumer demand for voice devices such as Amazon Echo and Google Home will generate $3.5 billion by 2021. The travel website Skyscanner, for example, offers travel booking via Alexa and Facebook Messenger. In the future, we will also see more pervasive use of facial recognition and biometric identification to assist with faster check-in, as was tested at Finland's Helsinki airport. They also ran a pilot with an online customer services chatbot, as well as display walls to provide relevant information about transfer flights and gates to passengers in their native language. As we are seeing with YouTube, Netflix, and other personalized recommendation services, there are similar use cases for deploying AI solutions in the travel and tourism sector to create tailored experiences where personalized content is delivered using AI that is proactive, relevant, timely, location-sensitive, and addresses the immediate need of the customer. Well Traveled is a wellness travel agency that captures clients' travel preferences, builds personalized itineraries, and supports travelers before, during, and after their trip. For targeted sales and marketing and improved customer services, it is essential to have customer segmentation that mines users' behavioral, demographics and metadata, geolocation, customer relationship management data, and social media data. For AI applications in revenue management, clustering and supervised classification machine learning techniques are typically used for segmenting customers on how price elasticity differs from traveler to traveler by making use of input features such as purpose of travel, returning or new customer, age, marital status, customer lifetime value, and user behavior and preferences. With customer segmentation and insights with respect to demand and supply, different pricing strategies can be personalized for travelers. Demand forecasting provides key information for pricing across customer segments and allows for selecting an appropriate distribution strategy. Dynamic pricing allows hotels to offer variable room rates and airlines to offer variable ticket prices based on demand and supply in order for them to quickly react to changing market values to maximize revenue. AI enables the decision-making processes in yield management to be automated as yield tactics are selected for different customer segments as it focuses on optimizing profit and revenue, whilst, for example, controlling occupancy rates and utilization of rooms, hotel facilities, restaurants, hotel casinos, and conference rooms. As in the case of the media and entertainment industry, AI is also used to generate email and video content for travel and tourism related communications, curate content for intelligent recommendations, analyze social media for profiling and determining sentiment, enabling intelligent customer relationship management for smarter loyalty programs or sales insights, assist with the click and conversion optimization for travel products and online advertising campaigns, enhance augmented reality applications to improve the overall visitor experience with interactivity and instantly accessible information, and provide video, image, and voice recognition systems for travel purposes. In an Emerald Insight paper, a critical overview of the impact of AI and robotics in the tourism sector is provided that highlights how AI is enhancing the experiential services in tourism, but also emphasizes the irreplaceable role of the human touch and the importance of ensuring data privacy and security. The paper mentions some future AI applications where travelers can select the option to transform their entire room into a virtual 3D world that looks like their favorite destination spot, robots serving hotel guests, and the use of visual positioning systems to provide location-based experiences via live views of the real world and visual landmarks.